All right, today is June 15th, 2022. It's 7:56 a.m. And now I'm going to turn on the Muon physics device again. As you can see, it immediately started detecting as it did before, and approximately the same rate. In fact, I'm going to turn on the computer simulation again. Well, not simulation, the computer measurement device. Configure COM3. And start. And one can see that the same rate will be detected. Approximately. So approximately 5-ish muons per second are being detected. This time I'm just going to use a collection of shorter clips to show that everything still runs the same regardless of the Earth's rotation, like angle, and, the time. And also just to show, the scintillator is, the pulse is at approximately -7 volts. And even when I take out this voltmeter just measures the voltage of it. Sorry, multimeter. And if we plug it into this, the threshold voltage, we can see that it's running at approximately 0.211 volts. We don't actually need this, we're just using it to check stuff. However, even after all this time, still no decays yet. Oh, we can see it now though. There have been a few decays. So interesting thing to note, I've just realized. The number of muon decays seems to jump whenever I unplug and replug in this computer. There's a laptop I connected to the other outlet. Now watch what happens when I unplug and plug it back in. The number of muon decays always seems to spike. Alright, out, in. And I don't know why. Maybe it's just coincident with the refresh rate? I'm going to do it again. Unplug. Plug back in. Well, we're going to leave it plugged in for the rest of the time, so it shouldn't affect it. I'm going to restart the simulation, the data collection without that. Restarting it now. Oh, oops, connected to the wrong thing. Still measuring the right amount of muons. And it was before and after we plugged in the computer, which was seen earlier in the clip with the first jump. It was coincident with the first big jump in muons detected, muon decays. Alright, we'll be back later. I have connected the oscilloscope pulsar directly to the muon detector. Let's see what the computer outputs then. So that's what happens if you connect the pulsar directly to it, so it does work. Alright, here we are again with more muon physics. So we got the muon detector going off here. And oh, by the way, it's now 10:17. Same day. So that's about the same rate as before. In fact, we'll see it's the same rate once I start the detector. Yes, that is indeed about the same number of muons per second and stuff. Not really any decays yet, though. It's working. I did change the scale of the oscilloscope, I think, but it's about the same. Watch. Same thing. Nothing happens when I put my notebook on over the oscilloscope. I hover the notebook over the oscilloscope. Let me try to do this. Can you see? Yeah, this can see the muon detector and stuff. See, I put the notebook over it, still nothing. Put the notebook all around, nothing. Under, nothing. Muons aren't really interacting with it. Still coming down though. I just checked it. I did a bunch of stuff with it. I connected it to a sine wave generator. It's properly picking up signals, which in this case is the decays from the muons. The muons are decaying or slowing down in there, creating a few light signals. Oh, and now we have a few decays. 2 so far, which is great. And that's about the scale we'd expect. Here we got it. Experimental evidence of special relativity. It's literally happening, and this is the proof. I'm gonna turn off the audio. But it's still happening, same rate and stuff. Experimental evidence of special relativity. It's really happening. Alright, well, I'm out of time for today, but as you can see, it's real and independent of the direction, rotation of the Earth, so it's pretty cool. A quick aside in addition to the last part, while I was rechecking everything, it turns out the voltage on the monitor here was slightly off, but I just readjusted it and it didn't affect it too much. It's the same rate. And this only happened when I was checking it between the clips in this video, so muons are still coming down at a huge rate, and this is correct and true. And still getting the proper amount of decays. Same as before, same as in the other direction. Note that if I turn the pulsar on or off, the pulsar is on or off, it doesn't actually affect the rates at which muons are detected. Hello again. Quick thing I'd like to add after last clip. So, as we saw earlier, there's nothing like the oxygen, the stuff in the air, isn't affecting the molecules, the muons, too much. Sorry, they're all molecules. But, so there's nothing that could be affecting their decay time besides their velocity. And since the laws of physics are the same in all reference frames, as you'll see if you throw a ball on a bus, it's the same as if you were at the bus stop. They're not slowed down. Their time isn't slowed down for them from their own perspective. It's just from ours. So time is different for objects and entities in motion as they move relative to each other. And that's what we're seeing right here, experimental proof of. The fact they make it here despite the quick, small decay time that we saw means that, and as you saw, they would only make it like half a kilometer before decaying, yet they still make it down here before quickly decaying as they slow down, meaning that as they speed by, time is slowed down from, and this is physical proof of it. This is real. So I think that's just really cool. Emphasis on the really, because it's really happening, and it's crazy. Unequivocal proof of special relativity. Thank you for watching, and same as before, I hope you have an amazing day.